Morning everyone. Welcome back to the webinar. Hope you're all well. We have an exciting session. We're going to be talking about climate change. That's a bit of a doozy. And we're going to be discussing whether we are to blame, and if we are we doing enough about it? So I'm excited to get to that section. In the meantime, as usual, we're going to talk about markets. And we've been having an exciting time in the last month. Just going to share some slides. By the way, I think some of you listen to this on kind of a podcast mode. You don't see the slides, so I'll try and kind of refer to what I'm talking about for those who are in the car. But thank you all for listening. And if you do enjoy the show, do pass it on, share it, whatever, post it, how that works. I'd be grateful. Cool. All right. So markets. Well, we've had a couple of things. A little bit of a banking crisis. This chart I shared last time. Markets are in a nervous state. And I highlighted kind of spikes and insider selling, board members, management, who actually have the inside track in terms of what's going on in their companies. And they've been generally selling into these kind of what I call bear market rallies. And the market did come back after that latest bout of selling. And what I've highlighted there is the Silicon Valley Bank collapse, which is swiftly followed by Credit Suisse. And that kind of mini banking crisis is worth dwelling on, which will be my main kind of message for the markets today. So let's take a look at that, what was actually going on. Well, what was going on was this. And banks have kind of parked a lot of their assets in safe US treasuries, long-term treasuries. However, those safe US treasuries have gone down in value as interest rates have gone up. And they're sitting on about, what is that, $750 billion of losses across the banking system, which is, even for US banks, quite a lot. And Silicon Valley Bank got itself very much on the wrong side of that. It had to book that loss, and once it booked the loss, then people got concerned about its solvency, and people started putting deposits. And in this world of digital banking, you can just press a button, take your deposit out. So bank runs become extraordinarily quick and very scary. And of course, they feed on themselves. No one wants to be the last one out of a bank run. And so SVB was kind of a canary in the coal mine in terms of a problem within the banking system in the digital age, in terms of the potential for bank runs and the potential to take deposits out very quickly. So that's become a problem. And it's been a problem accentuated by the fact that you can get much better rates on your money in a money market fund. Look at this chart. You can get 4.5% on your money market fund in the States now. Actually quite nice. Your deposit rate in your bank is next to zero. Your bank doesn't pay you anything. So people have been switching from their bank deposits to money market funds. And this chart shows that happening. Money market funds, assets rising rapidly, US domestic bank deposits declining at the bottom there. You saw about $500 billion move, within a matter of days in the US banking system. Really quite alarming moves for the banking system, which depends on deposits for its liquidity. And what happens then is that post SVB, Silicon Valley Bank, the market then looks for the next weakest player to have a go at, because that's what stock markets do and that's what depositors do. This shows you Credit Suisse, which was the next in line. And Credit Suisse has had a checkered history in the last 10 or 20 years. These are just the fines it's paid for various misdemeanors, $5.5 billion in 2017, etc. These are not life-threatening numbers for a bank of that size. They've got up $500 billion of assets, so they're not life-threatening. However, once people withdraw their deposits, which is what then happened, it becomes self-fulfilling bankruptcy. Spurred, I'm sure, by the delicious irony, for those who remember, Lehman Brothers, of course, suffering a similar fate in the 2008 global financial crisis, being really the first shoe to drop in terms of being allowed to go bankrupt, Lehman in September 2008. And the chairman of Credit Suisse is, of course, Mr. Lehman. So maybe that was the reason they lighted on him, I'm not sure. Anyway, I enjoyed that irony. And when the market looks at this, these are credit default swaps, CDSs. These are bets that the bank is going to go bust. And the price of that bet went through the roof because it became very valuable. And that's an indicator that the bank or other institution is in enormous trouble. And on the Wednesday of that week, Credit Suisse borrowed $54 billion from the Swiss National Bank. The Swiss National Bank moved in very quickly because deposits were flying out of the bank. So they had to shore it up with $54 billion. That was the Wednesday. By Sunday, it was all over. And UBS had bought Credit Suisse. Those are the two big Swiss banks. They're both part of the top 30 systemically important banks globally, which are meant to be protected and too big to fail. UBS bought Credit Suisse for $1 billion. Credit Suisse has been a venerable Swiss institution since 1856. And it's gone in a weekend. It's extraordinary. And if you'd missed the headline on the Monday, you probably wouldn't even know it had happened. It was extraordinary swiftness of events here in the banking sector. And it's calmed down since then. I don't think this will be the end of it. And I think we're going to see fragilities, in the financial system generally. And what's happening now, of course, as a result of this, in the real economy, you've got all these banks with their deposits. They're getting a little bit more nervous. They're not going to lend them out because they're going to hold them. And a way to describe that is that they're tightening lending standards. This chart shows you the extent of tightness of lending standards in the banking system. And what tends to happen is banks kind of withdraw as economic circumstances become worse, or their own circumstances become worse in this banking crisis example. So 2000, lending standards spiked, we had a recession. 2008, lending standards spiked, we had a recession. The same is happening now. So banks are withdrawing, and at the same time, of course, interest rates are very high. And this shows you, I found this quite interesting, this shows you the interest rate on credit cards in the States. So the amount you pay on a credit card. And this only goes back to 1995 because credit cards are a relatively new thing, strangely. You only really came in the early 90s in a proper way. And your interest rate on your credit card has gone from, what's that, a low of kind of low teens, 12, 13%, to 19%, the highest level ever. So close to 20% interest rate on your credit card. That is killing consumers. So a recession, as this slide attempts to show, is coming. And the Fed overnight, in fact, recognized for the first time that a mild recession is possible later this year. That's what they always say, because they're not going to say it's going to be a bad recession. They probably know it's going to be. And this shows you the fully fed manufacturing index, another indicator of recession. So surveys of manufacturing companies, are things good or bad? And in every single circumstance, when that measure gets below, what is that, below minus 20, 1970, 73, 1980, 81, 1990, 2001, 2008, and 2020, every single time that went below minus 20, which is where it is now, we had a recession. I think that's bad news. Put another way, I found this chart enjoyable, in a morbid kind of a way. The Fed hikes until something breaks, which is really what's happening now. From the left there, the Fed hiked until we got the tech bust. In 2000, in 2007, 2008, the Fed hiked rates until the housing market broke. And this time it's hiked rates actually very aggressively, and smaller regional banks are breaking. It's a problem. And in the meantime, strangely, inflation is not coming down yet. We've been saying this for a while. This is UK inflation. Headlines still above 10% in the UK, can you believe it? But the important one is core inflation, which is the less volatile one. That's the kind of, tends to be the sticky one. And that's the one the central bankers look at. It's the important one. And you can see core in that chart is stuck in the UK at kind of 6%. It's also stuck in the US. We had an inflation print overnight, and the core rate of inflation in the US has gone up from 5.5% to 5.6%. It should be coming down to 2%. It's not. It's proving sticky. So rates are going to have to stay higher still for longer, despite what's happening in the banking system. And you've got these pockets of fragility now. This again is actually UK house prices. Let's look at this chart. So this is the red line. Price to income ratio. Okay, price to income ratio. This is the affordability for first-time buyers. For those of you with children looking to maybe buy a house somewhere, make a life for themselves, and wherever they are, house prices are very expensive for them. The price to income is extremely high. And this is one example, which is the UK, and the price to income ratio is gosh, that's 50% higher than the previous boom in 1988, 89. And we know how that ended very badly. So house prices are expensive, commercial property is still expensive. And as rates have gone up, that's a problem, and house prices and property prices are likely to come down. There's around $30 trillion of commercial property in the States, which is pretty levered, i.e. holding a lot of debt. So that's probably the next shoe to drop, I suspect. And in the meantime, this is probably, I think, my final chart on the market and the economies. I always find this interesting. I've shown this before. The red line, to remind you, is the savings ratio. I think, again, this is the United States. So this, the amount people save out of their income. And the savings ratio has collapsed to very low levels. In other words, people are spending their income as opposed to saving it to keep themselves going. And the blue line is their credit, their consumer credit, their credit card bill. And it's gone through the roof. So they're spending their income and they're borrowing on credit cards at 20%. That can't go on for much longer. They're trying to keep going. They're post-COVID, they're out, they want to do things, but at some point that hits the wall. And the market, meanwhile, that was not my last chart. The market, meanwhile, has bounced a little bit or kind of stabilized, kind of a thing in the face of this banking crisis. Certainly this year to date, it's gone up. But look how narrow the market is. If you've got a narrow market, it's a bit of a danger sign. So a narrow market means very few stocks are adding most of the value. So the S&P 500 names, the 20 largest stocks this year have added close to $2 trillion of value in their own right. The remaining 480 have added 170 billion, i.e. nothing. So very narrow market. And that tends to be a danger sign in terms of market levels. I've shown similar to this before. It does remind me, I hate to say, not of 1973 because I wasn't around then, but it looks exactly the same. It certainly reminds me of 2008 when you had these quite pronounced bear market rallies and people thought everything was going to be fine again. Turns out it's kind of not, but you feel it's okay because the market's kind of going up. And you can see these charts at 73, you get a bull trap is what we call it. In 2008, a bull trap, and then the market comes off. We're in a similar, I think, kind of a bull trap right now. Let's see. Finally, goodness me, gold. You know, I've been going about gold for a little while. Gold is a safe haven in the uncertain times. It has actually performed, I'm glad to say, pretty well. It's above $2,000 an ounce now, which is great. So hopefully holding a little bit of gold. This is the speculative interest in gold, the number of call options on gold in the latest, in the last month. So the call options on gold, bets that gold is going to go up, has gone through the roof. So interest is coming into the gold market. So hopefully you're exposed there and hopefully enjoying a little bit of positivity there. All right, so mind your eye on the market. That's been a consistent message from me. Okay, climate change. This is a kind of an interesting and a controversial area to be discussing. So I thought I'd kind of head into it and do some primary research. So I spent a lot of time reading the IPCC report, which is the Intergovernmental Panel on Climate Change, IPCC, which is the global body, which prepares papers for COP26, COP27, COP28, the Paris Accord, etc. And let's dig into the numbers. Let's see what's happening with climate change. Can we try and answer, are we responsible for this? And if we are we doing enough to stop it? It's kind of the question of our age. I find it a very interesting piece of research. Right, firstly, is the planet warming up? Unequivocally, the planet is warming up and warming up pretty quickly. That I can say without fear of contradiction. You can see it in the surface temperature, i.e. in the air on this chart. The air temperature is going up, we'll show you that. Ice sheets are declining on the right there. Land temperatures at the bottom there, again, are going up. Seasons are changing. And ocean temperatures and levels are going up. So let's just show you each of those. It's quite interesting. All right. Okay, this goes back to 1880. The reference point for global temperature change, by the way, is 1850 to 1900. That's taken as the kind of 0 degree thing, 1850 to 1900. So that's the kind of benchmark, and everything's measured against that. So against that, you can see that temperatures have gone up by 1 degree centigrade over the last, give or take, 50 years. So that's actually quite a lot. 1 degree centigrade, keep that in head. The Antarctica Ice Sheet, could have showed you Arctic, could have showed you Greenland. Ice sheet has contracted a large amount, 151 billion metric tons per year since 2002. And that is a lot. These are figures from NASA. Sea levels have gone up. Again, this goes back 25 years. Yes, since 1993, actually 30 years. So sea levels are up by 100 millimeters. That is 10 centimeters, or for old school people, 4 inches. So it's about a span. So sea levels are up by about a span of your hand, which is nothing compared to what they've been up in the past. They've been up like 5 to 25 meters in ages gone by. So 4 inches is not actually very much yet, but they are up. So let's recognize that. And they are warming. So oceans are rising in temperature. That means they expand, and that means their sea levels rise. Okay, so I think it's pretty clear that the planet is warming up. And you can see this in this chart, global mean temperature. This goes back 2,000 years. At the bottom there, you can see global mean temperature is pretty flat, and it has been going up. The shaded area, importantly, where it gets alarming, is the forecast. It's not what we've done yet, okay? So the 1 degree centigrade is actually quite small on this chart. So people tend to show these forecast charts, which look really alarming, but they are forecasts. And it's for carbon dioxide, methane, nitrous oxide, those are the 3 main troublesome gases, and the global temperature. So they all look alarming, but those are the forecasts. They're not heading in the right direction, but let's not get ahead of ourselves. So let's put that temperature rise in the context of the last 60 million years. Okay, so is the temperature rise this time a lot or not? Okay, this chart shows you, if you go from the left to the right, from the left is 60 million years ago, and the y-axis is the global surface temperature relative to 1850, 1900, that benchmark level, yeah? And you can see 60 million years ago, we were around 10 to 15 degrees warmer. So not 1 degree, 10 to 15 degrees warmer 60 million years ago. And we remained 5 to 10 degrees warmer for the next, 40 million years. So that was a very warm period for the Earth, much warmer than we are today. Those temperatures then came down, Ice Age, etc., and they came down to kind of -5, so 5 degrees below where that 1850, 1900 thing is. So we're a glacial period, Ice Age period. Then on the right, from 20,000 years ago on, we enter what's called an interglacial period, so a warming period for the Earth. So that interglacial period, the Earth has been naturally warming as the Ice Age recedes. And we've gone from whatever that is, kind of -3 below to a 0, 1850, 1900. And then we kind of warmed after that in this century reasonably abruptly by 1 degree. So 1 degree in the context of 60 million years is not very much, but it has occurred quite quickly. And it has occurred at a time when the Earth was kind of cooling again. So that's a little bit unusual. Okay. And you can see this, I want to show this because this kind of shows the pace of increase of temperature, because that's important. For me, is are we warming, and are we warming quickly? Same data, but not back quite so far. So this is 10,000 years ago on the left. Again, temperature on the y-axis compared to 1850, 1900. So 10,000 years ago to 5,000 years ago, we were warming, that kind of natural warming period. We warmed by about ½ degree, maybe 1 degree. But that took 5,000 years. Okay, 5,000 years to warm by a ½ degree to 1 degree. Flick to the right of the chart, the purple line is this century. And you can see that really in the last 50 years, we've warmed by a degree. So what previously took 5,000 years is taking 50. So we're warming actually very quickly. Again, that is, in my mind, unequivocal. Okay, so we're warming up. That is clear. Are we to blame? That's the exam question. Okay, it's about CO2. So to remind people, CO2 we emit mostly from fossil fuels. We burn carbon, it goes into CO2, goes into the atmosphere and traps heat. So sun's heat comes in, goes through the carbon dioxide, by the way, hits the Earth's surface and reflects back up to the atmosphere and gets kind of trapped, well, naturally trapped, because it kind of warms us up, that's fine. But carbon dioxide is trapping it to a greater extent than would be ideal, to say the least, is the premise. Okay, so too much CO2 is trapping too much heat in. By the way, the reason sun's rays come through the CO2 happily, but then get trapped on the way back up, is because the sun's radiation comes in a short wavelength, goes through it, but gets bounced back up at a slightly cooler temperature at a longer wavelength, which then gets trapped by the CO2. There you go. CO2 levels have clearly, again, this is unequivocal, been going up. This chart goes back 800,000 years, and we've been kind of 200 parts per million to 300 parts per million-ish. We're now at 400 parts per million, and it's happened very quickly. Again, it's happened in the last 50 years. So CO2 is up a lot. Let's set that in the context of, is that a lot of CO2 in its own right? Okay, so 400 parts per million, go back to that chart, 400 parts per million, looks like a lot. Is it a lot in the context of the last 450 million years? They get these carbon measurements from ice cores, by the way. You can measure the carbon at certain stages of the ice core. Okay, so these I think are relatively accurate. Okay, let's go back 450 million years. Look at the y-axis on the top chart. CO2 concentration is in the thousands. Okay, so 400 parts per million today. Back 450 million years ago, 200 million years ago, it was kind of 1,000 to 2,000, not 400. It was 1,000 to 2,000 parts per million. So what is that? 5 times as much in that era. And remember, that era was very hot. Okay, so but a lot more carbon. Carbon dioxide levels in the atmosphere have been coming down, down and down, down, down and down. So these charts go very long term at the top, 55 million years ago at the middle, and you can see it's still 1,000. 1,500 parts per million, but still coming down, and then 3,500 years ago at the bottom there. And you can see again it's coming down, and it's kind of settled in this 200 to 300 parts per million range, and then spiked to 400. So compared to history, it's not actually that high, but it has spiked very quickly. Okay. I hope you're following this. It's a convoluted argument, convoluted discussion. This shows the same thing, which again is 60 million years ago, 1,500. I'm not going to do this chart, actually. I've done that. I'm going to confuse things. All right. So carbon dioxide has spiked, but it's spiked from relatively low levels compared to history. Okay. What the scientists then do is say, okay, so is it the CO2 which is causing the warming, or is it just natural effects? And they run these extraordinarily complicated models, and there are many, many surveys done of it, and the IPCC thing sums everything up in kind of a meta survey. And there are a lot of surveys, kind of 90,000 of them. And they all appear to agree, based on their models, this chart. Okay. So the attributable change in temperature to certain factors. All right, look at the bottom line. The important ones are, 1 along, net human influence, and then 4 along, other human forcings. Oh, I beg your pardon, natural forcings. So the natural forcings is the natural evolution of the Earth, and according to the analysis, that has had very little effect on temperature. So the 1 degree rise in temperature, the scientists are saying that is not to do with natural forces. It is pretty much all to do with the net human influence. Okay, so scientific surveys, facts, models, and not actually facts, models say that we are responsible. It's the CO2 we're giving out. They're unequivocal about it. Let's dig into that one more level. This chart I found very interesting from the IPCC. To read the top of that chart, it says observed warming is only reproduced in simulations, i.e. the models, including human influence. Observed warming today is only reproduced in simulations including human influence. What that is saying if you look at the chart, natural causes, so they do their models, okay, and natural causes cannot explain the increase in temperature we've seen. Therefore, the only thing left is the increase in carbon dioxide. Therefore, that must explain the increase in temperature. So there's a chemical link between CO2 and an increase in temperature because it traps the sun. Fine. This does not provide a direct, definitive causal link. What it does say is that it kind of has to be because it's the only thing that's left. It could be some other natural cause we don't know about yet. That's a possibility. But in terms of the overwhelming evidence in these studies and the models is that the only thing it could be is carbon dioxide. So let's look at that. Let's look at these periods in the past. This is not really conclusive for me, but just navigating for a second. On the left there, the kind of green at the top. Okay, this is 3 million years ago. CO2 was high. Okay, and remember that very hot period, kind of 3 to 5 million years ago. The temperature difference was like 2.5 to 4 degrees hotter. And the sea level was 5 to 25 meters higher. Catastrophic stuff. The Earth was crazy back then and also had quite high CO2. The other period of global warming, which was, where are we here? 125,000 years ago, when it warmed by 0.5 to 1.5 degrees, carbon was high, but not that high. And therefore, is that causal? Today, it's a little higher in terms of carbon, and it could get much warmer. So the cause and effect in carbon and temperature is not absolutely clear from the actual history. How is this global warming different to before? Okay, this is the IPCC report. It is warming almost everywhere. That's different to before. It is warming rapidly. That is true. The warming reversed the long-term cooling. That is true. And it's been a long time since it's been. These are all, I think, true. And you can see it's warming almost everywhere by this chart, which is, you can see, again, the temperature up by 1 degree. North America, Northern Europe, East Asia, Americas, Africa, they're all up by 1 degree. That's quite unusual, apparently. It usually kind of happens somewhere, but not everywhere. So, yeah, there is something clearly going on, and it is being linked to CO2. My last point on CO2, then we'll get into what we're actually doing about it. There's always wrinkles to every argument, and this needs to be assessed. And according to NASA, the amount of carbon dioxide in the atmosphere can have this effect in terms of global warming. However, the composition of the atmosphere, it turns out, I didn't know this, nitrogen is 78% of the atmosphere. That's what you breathe mostly. Oxygen is 21%. So you're not breathing much oxygen, you're actually breathing mostly nitrogen, but we make use of the oxygen. All other gases in the atmosphere, 1%, and those are listed on the right. So carbon dioxide currently is 0.037% of the atmosphere, 0.037%, i.e. 370 parts per million. 0.03. So that's small. That's kind of a small proportion. And yet it's having this very large effect in terms of warming. You know, that's a stretch in terms of one's leap of faith in that. Again, NASA work suggests that can be expected, and carbon dioxide does have effect on temperature, but a relatively small amount is having quite a big effect on temperature. So that's a wrinkle in the argument, I would say. But let's see what we're doing about it. And are we reducing? If it is carbon, and all the studies suggest it is, if it is carbon and it's us, what are we doing about it? Well, not very much, is the truth of it. The Paris Accord for 1.5 degrees, to remind you, said that we as the world, I'll give you a break from the slides here. I've been talking a lot. The Paris Accord, let's take a breath, said that to keep the increase in temperature to 1.5 degrees, we're already at 1, by the way, so keep it to 1.5 degrees, maybe 2, then our carbon emissions have to basically halve by 2030 compared to 2019, which is the baseline, down 43% to be precise. So we're basically looking to halve our carbon emissions by 2030 It's 2023 today, so we're kind of halfway through our kind of halving aim. What have global carbon emissions actually done? Have they halved anywhere near? No, they're at all-time highs. Again, this kind of surprised me. I knew it was bad, but this is like, so 35 billion tons of carbon emissions, dioxide emissions per annum. Yeah, well, good work. So we're at all-time highs. Why are we at all-time highs? Well, we'll come back to this in a second. But let's look at where the carbon comes from, first of all. What is the problem set? I found this chart pretty useful. Agriculture, yes. Waste industry, yes. Cement is quite big on the left there, but the red thing is energy. Massive energy usage in industry, in transport, in buildings, in aircon, in steel production, you name it, it's energy. So how does that energy break down? And we'll come back onto that in a second. But who's to blame for the carbon dioxide emissions? Let's get that done first. These are cumulative CO2 emissions, okay? So how many in total cumulative over time? And it's clear it's the United States and Europe. And CO2 stays in the atmosphere for quite a long time. So this is relevant. It doesn't go up and go away again. It actually stays there a long time. So the US and Europe, not good. And you can see this in cumulative CO2. The United States has put in 400 billion tons so far. The European Union has put up 300 billion tons of carbon emissions into the atmosphere. Very large. But of course, look what's happening now, China. So China is increasing very rapidly, as is India at the bottom there. And I'll come back onto that in a second. Oh, here it is. Okay, who emits the most CO2? This is on an annual basis, current. So who today is emitting the most CO2? And it is China, but by an absolute street. Close on 20 billion tons of CO2 per annum, which is 53% of global emissions. And you can see that here. These are the annual emissions. You can see China's gone from 2 billion to whatever that is now. It says 12 billion on this chart. So these are annual emissions, and it's exploded. And is showing no signs of coming down. The United States, you can see, has rolled over. The United States and Europe, which is not on here, are actually playing the game reasonably well. We, the West, the United States and Europe, I should say, are reducing emissions. That is true. China and India are going berserk. I found this interesting just for noting. These are the annual share of global CO2 emissions. It's only interesting because it was the UK back in 1750, around the Industrial Revolution, which is contributing 100% of global carbon emissions. And of course, that's down a lot, and China's increased. This is per capita. So again, the United States is doing a good thing, the UK is coming down, but China, even per capita, is going up. I think I made that point. And China, by the way, is, in 2022, last year, China approved 2 new coal-fired power plants per week. 2 new coal-fired power plants per week. So China has 1,120 coal-fired power plants, 1,120. And that's going up by 2 per week. India has 285. The US has 225. So 1,100 in China and increases by 2 per week. So that is not coming down. So that's not great. So what do we do about it? And of course, there's a massive shift into renewables and away from fossil fuels, or attempting to, particularly in the West, and particularly putting money into renewables. The problem is this chart. So this shows electricity only, but total energy is at the bottom. That's the relevant one. And total energy, including electricity production, total energy includes transport, so vehicles and heating, direct heating. Currently, oil is 33% of our energy. 27% of our energy comes from coal and 24% from gas. So that is 40, 51, 54. That's 85% comes from fossil fuels today. 85%. And renewables, on the right there, are very small. And so switching from one to the other is going to take a very long time. And it's going to require an enormous amount of investment. This is putting those things in percentages. I'm not going to belabor the point, but coal at the top, a third, gas, hydro is quite big. The point being, it's going to take an enormous amount of money to pour into renewables, wind, solar, hydro, and actually nuclear. Nuclear is a big one. And even once you put the money to renewables, as we all know, they're not baseload. They're not on all the time. The wind does not blow all the time, and we don't have enough storage capacity to store the wind energy whilst the wind's not blowing. So there's issues around renewables, which nuclear can solve because it's baseload. It's on all the time. So you've got a very small amount of renewables, and it's going to take a while. And look at this. To reach net zero targets, this is the amount of increase in each of those technologies which needs to happen. Okay, so you need 6 times more wind power. That actually looks low to me, to be honest. Solar 14 times, electric vehicles 14 times, green hydrogen 200 times, carbon capture 100 times. So we're way off where we need to be, and we need to invest tens of trillions of dollars in renewables. And at the same time, and this is part of the problem, weirdly, this shows you the amount of capital expenditure in fossil fuels, okay? Looking for new coal, looking for new oil and gas. Bad stuff. However, and because it's been deemed bad stuff, there's very little investment being funded into it. It's very hard to fund these projects in fossil fuels anymore, which de facto is a good thing because it puts CO2 into the atmosphere. However, you're turning fossil fuels off very quickly, and renewables are not coming through quickly enough. And that gap is causing electricity prices, energy prices to spike. It's not just Russia and Ukraine, it's a general trend where they are spiking. And that's a big problem for poverty and people's ability to keep themselves at the right temperature and eat at the same time, because those things also go to fertilizer to produce crops. So the price of everything is going up. So our bridge to renewables is proving very tricky in terms of the price of things. So that's a very difficult thing to do. And we need to be more cognizant of that. And in the meantime, we're short of everything we need for renewables. Lithium shortages. How China is winning the race for Africa's lithium. I'll make the China point, then I'm going to sum up. Look at this, the race to renewables, okay? I made this point before. The green metals we need, cobalt, copper, lithium, etc., for batteries, for solar and wind equipment. A, there's not enough of it around, and B, China has most of it, as well as Russia, and quite a lot in the DRC. The red thing in these charts is China, offshore wind equipment and manufacturing, onshore wind, solar, electric vehicles, fuel cell trucks, heat pumps, and electrolyzers. And you can see it's between half and all the market is China. So this brave new world of renewables, China is going to dominate. So geopolitically, there's an issue there as well. So what's the summation? Let me see if I can get this toggle right. Oh, okay, it's doing something else, not to worry. Let's share it with the screen. Okay, summation. The world is warming up. The studies imply very strongly that carbon is the culprit because it's the only remaining culprit they can find. And you know, we need to do something about carbon anyway. So let's reduce our fossil fuel load. However, let's be sensible, in my view, about the switch from fossil fuels to renewables. Because in practical terms, you're growing something very small and contracting something very large. So the switch is very difficult in terms of the bridge, and it's coming through in increased pricing. So let's be sensible about the switch from carbon to renewables. Let's do it fast, but let's not go completely crazy and cause different problems for the world. As part of that, let's invest a lot more in nuclear. Nuclear's baseload is now deemed a green energy, I'm glad to say. So nuclear is an important baseload for the world. And most importantly, and I'll leave you with this, we need to adapt better to a warming world, because the world is warming. That is clear to me. Whatever else is happening, the world is warming. And be it better sea defenses, because sea levels are going to rise. Places are going to get hotter. There's going to be less ice around, therefore more sea. And things are going to get difficult. We're going to get crop failures. We're going to get natural disasters. We're going to get more earthquakes. By the way, as glaciers recede, it turns out glaciers kind of cap the Earth's crust in place because they're so heavy. Once you release that pressure, you get more earthquakes. So Turkey had, as an example, had 14 glaciers, most of which are gone now. And that was part of the reason, they think, for the dreadful earthquakes we saw in Turkey stroke Syria in the last few months. So you can see more natural disasters. So we have to prepare ourselves for that kind of a world, because I think it's going to be very hard to avoid it. And in the meantime, let's do everything we can on carbon, but let's make the transition sensible to renewables, which is our future. And in the meantime, this puppy's warming up. That is an unequivocal fact, and we need to get used to it. And on that happy note, I will leave you and wish you good luck for the next month, and speak to you next time.